time to discuss some TBC and SiteVision resources and then talk about the next TBC Power Hours coming up in March. All right, so without further ado, I'll go ahead and jump right into the Trimble Business Center. So just a little bit of background of this project here. We had some of our interns go out in the back of the Trimble office in Westminster, Colorado, where we have a drainage ditch. We thought it would be a good idea to kind of shoot in the topography in there, and then also show in some of the pipe modeling for later on to view in SiteVision. So just a little bit of a background, we have SX10 data as well as X7 data. And as you can see, these come in separately, one up north and one down south. And the reason being is when importing X7 data into a project, you'll have to geo-reference the data into the correct position because there's a scale factor being applied for all scans that are halfway between where the project is and the origin of the coordinate system. So just a little background information there. And we'll describe to you how to geo-reference and marry those two data sets together here in a little bit. Also, if I zoom in here to my SX10 data, you can see that I have all my shots and topography. We did a little bit of modeling using the utility module here, and then using the MSI manager with site improvements. As you can see, I've loaded in my nodes and my head walls, junction boxes, etc. Just for the sake of time, we could talk for an hour just on modeling with pipes. So please reach out if you're interested, and we can send you tutorials to learn some of the pipe module later on. Other than that, I have a little bit of pre-work that I did. So I drew this boundary, so surface boundary line here, and then also a flow line right here to match the inlets and the pipes with. So with that being said, we're going to go ahead, and now that I have my SX10 data in here, I see my points, but I don't see my line work. So what I'm going to do is go ahead and go to the Survey tab and process my feature codes. And I know that all my survey data is within this JXL file, so I'll go ahead and click this box, Process Sources, at which point you'll get a window that pops up and says, do you want to view this processing report? And for those of you that don't know, you can go ahead and hit yes, and it'll pop up in another pane, or tab if you will. And it'll show off some good reference data, so the coordinate system, the datum, zones, and this is good to print off and keep in your file folders or project folders for later on, just so you have it. That, I'll go ahead and close out of here. And you can see how this data came in pretty nicely. I can see that my grate closed off. All the lines look good here for the canal line. And I also have my back patio, and that'll make sense a little later. But when I do this QA, QC, and TBC, I can see that for whatever reason, the surveyor did not put arcs in this line. So just a quick edit, it's bothering me. So I'm going to go ahead and click it and right-click, edit. And there's an option here so that I can put in a smooth curve. And what I'm going to do is toggle back and forth between this guy here and the current segment. And what I'm going to do is I'm going to toggle until that red line is where I want to make my edit. And then from there, what I can do is I can go down to the type and hit best fit arc and save. And you can see that change happening right there. And what I'm going to do is keep toggling around until I'm happy with my edits. And this will look a lot better later on when I make my surface. And I'll go ahead and close that when I'm happy. And now you can see this looks a whole lot better than just straight lines across. So with that being said, once I've done my QA, QC, and I'm happy with the processing of feature codes, what I'm going to do next is actually go ahead and open up another view. And we still haven't married these two data sets together. So the best way to do this, I believe, is to go in here and right-click on that second plan view and do new vertical tab group. And what that does is it allows you to zoom in on one side to your survey data and then the other to your scan data for the X7. So I'm going to zoom in here. And now that I have those two aligned in a vertical tab group, I'm going to go over to my point clouds tab, and I'm going to go ahead and hit Geo Reference the Scans. And you'll notice the window pane pop over here in the right-hand side. At which point I'll grab my first point that I want to match up. So I'm going to click in this box, and I'm going to go over here in the survey data side, and I'm going to click this first control point, CP1. And as I grab that, you'll see it fill in these boxes and then shift over to the second point. So I'll go ahead and grab the second point in the other pane. You can see the station set up. And now it's grabbed those 2 points and it's ready to grab my second reference point. So I'll go to CP by the grill, click this one, go find it in the other. It's now ready for my third point. And because I'm familiar with the project, I know that I shot the third control point down here. And again, I'll go find it in this pane as well. All right, now we recommend that you do at least 3 when you geo-reference. So now that I have 3, I'm going to go ahead and hit geo-reference. And you'll see the X7 data show up on the left-hand side. There we go. I'll go ahead and close this pane, recompute the project, and I'll also close out of that other plan view now that I don't need it. And if I zoom out, you can see that my line work is really showing up well. It's aligning with the grate system, also along with the canal, all the way over. All right, so it looks pretty good. Now the next thing I want to do is clean up some of my data because it's just a lot going on right now. So I'm going to turn off my total station vectors here. I'm going to turn off these image frames, and I also want to show or turn off my point IDs just because I did that QA QC already. And that just cleans it up a little bit. So from here, I'll open a 3D view as well. And I'll zoom back into the survey data to have this align. And so the next thing I want to do, since I want to create a surface within this boundary line using the point cloud data, the best way to do this is to grab all of this data and do a classify regions so that once I classify everything, I can just turn on my ground points. So with that, I'll go ahead and swipe over all this scan data. And within the point clouds tab, I'll go ahead and classify regions. I want to grab all the classes to extract them all. So I'll go ahead and hit extract. And for the sake of time, I actually saved another project that already had been classified in another window. It shouldn't take too long, but we'll just go ahead and jump into another one. It decides to transfer over. All right, so as you can see, after running the classification tool, I have everything segregated out, and I can see all of those down here in the View Filter Manager. If I go down to Point Cloud Regions. So this has all the segregated regions down here that I can turn off and on. At this point, I'm ready to turn off all of them and just turn on the ground. And you can see that it picked up all of the ground within this boundary pretty well. And then from here, Since I know that this area is going to be a lot of vegetation within this drainage ditch, the best thing to do to create a smoother surface is to grab this. So I'll go ahead and click the ground, and I'll go to point clouds, and I'm going to go ahead and sample the region. And what this will do is sample down the point cloud to only grab a certain amount of points and really kind of get rid of that vegetation going on in there. So you have a few options within this window pane. You can either do random or spatial, and then you can also assign it your names and things like that at the top. And then also assign it a number of points to extract within the millions. And if you're ever confused within this, a good tip, again, is to use the function F1 key, and you can always get some detailed information using the help. So there's good reading material in there if you're ever stuck and you don't know what to do. So for this demo, I'm just going to leave it as is. We'll just name it sample, and then we'll do random, and we'll just do 0.5. And when you're ready, I'll go ahead and hit store. And you can see that it kind of only extracts, 500,000 points, which really helps me create a better looking surface later on. And you can see that it adds that into the point cloud regions over here on the left-hand side, which is really nice. If you don't like this, you can always turn it off and play around with this extract points value in here, and up it or lower it as you need going forward. So once I'm happy with this, I think I'm ready to create my surface. With that being said, I'll go ahead and click this, go to my surfaces tab, and create. Another thing to keep in mind here is when you're using the ribbon, we designed this to work left from right. So you'll notice we'll create the surface now, but then we'll add the surface members in, and then we'll create the boundary later on. So within this create surface, I'll go ahead and create it now. You can see the new tab pop up on the right-hand side, or the window pane. We'll just call it new surface. We can call it unclassified. You all have all these different classifications to name off here. We can just call it as built for now. I'll go with a medium green color, and it already has the ground selected. So I'll go ahead and hit OK. Let the project recompute. Did not pick up this. It would do this when I'm doing the power hour. So this is the first time it's just cut this off. Usually it goes all the way over here. So let me go ahead and redo this. So I'm not happy with this surface. I'm going to click this off as well. Go back to my point cloud regions. I'll turn on the original ground points. And I'm going to redo this here. So I'll sample by region. I'll make this a little smaller so that it picks up. Store it. And I am actually not happy with that either. So what I'm going to do is I'm just going to go ahead and go off the ground points. Apologies there. That's the first time it got cut off. So with that, I'm going to go ahead and select the ground. Go to surfaces. We'll create a new surface here. And we'll give it a new name. Call it drainage ditch. Give it a medium gray color again. And hit OK. And it's still good. Awesome. All right, well, we'll just go ahead and run with this for now. Apologies for that. I don't know why that's doing it, but you'll see later on in the demo that the surface that we made earlier will go along this flow line. And as we go on here, the next thing I'm going to do here is I'm going to add in my surface members. So with that, I'll go ahead and click that and then come over here and I'm going to add in I'm going to come in here and select some of this line work that we shot in to add in as a surface member. Get the grates, sewer lines around here. And we'll also get the patio concrete pad. I definitely want to grab the flow line or the edge of road, and I'm going to add those in. Now, just to clear this up a little bit, I'm going to turn off my ground points and evaluate this surface. And now it looks much better here. You can see these pipes coming in, which is good. This is what we built off the utility module. And once I turn these point clouds back on, you'll be able to see how this lines up pretty well with the arch head wall coming in. I'm going to go ahead and zoom out, deselect, and I'm going to turn off my point cloud regions. And once I'm happy with the surface here, I'm going to go ahead and hit surface boundary. And what I'll do is I'll add in this boundary line. Let it do its thing here. And you can see that it cleans it up nicely. And now I'm only having the area I'm of interest highlighted or trimmed off. So at this point, I'm pretty happy with the surface. Everything looks good to me for modeling purposes to get it out to SiteVision. So I'm going to go ahead and click the surface. And there's one more thing I'd like to add. And click the surface. And I want to create some contours to go with this set as well. So when this pane pops up on the right hand side, again, you'll have some options. For today, I'll just leave it to the contours name. I'll leave these values here. You can assign it a layer. We can go with contours here. We'll just go by layer. And again, if you guys need any help, the function F1 key can tell you a lot. Just go. And what we'll do here is we'll go ahead and do a color by contours by elevation. And we'll also do smooth contours as well. And since I don't want to really see the labels, we're just going to put in a large number here for today. We'll hit OK. I'll deselect, and as you can see, we've got some nice contour lines to add in to the surface data. And once I'm happy with the visual representation here, and I'm ready for SiteVision, what I can do is go to Home, hit the Export tab, and within this pane, move this guy out of your way. Within the file format structures, just go ahead and hit the Construction tab, SiteVision AR Exporter, And here, I'll go ahead and grab everything in this viewpoint. And I can come in here to the file name and I can hit the ellipses. I can assign it to the file structure that I need it, give it a name, and go ahead and save, and I'll export that out to SiteVision.
Mind if I add something, Jeff?
Yeah.
All right, so when you do export something out with the SiteVision AR exporter, it won't just generate one file, it'll generate three. So you'll have either a JXL or .cal site calibration file. You also have a VCL file that'll be used for other Trimble products such as Earthworks, and you will have a TRB file, which is basically the model information optimized for viewing in SiteVision. So when you export all of these data from the TBC SiteVision AR exporter, you will need to upload all three files to Trimble Connect using the same, in the same folder, and assuming they all have the same file name. Because otherwise, if any of those three files aren't there, the model won't show up correctly on Trimble Connect. And another thing you can do as well is I don't think we are logged in this case, but if you are logged into Trimble Connect through TBC, you can also have the exporter directly uploaded to your Trimble Connect account as well. Save a few steps here and there.
Awesome. Thanks, Miko. All right. So with that, we'll go ahead and demo and show a pre-recorded video of how to use SiteVision out in the field. Go ahead and show that off.
Hello, and welcome to the SiteVision segment of this TBC Power Hour. My name is Miko, and today I'll be taking you out into the field in Westminster to show you our data set from TBC, as well as demonstrate a few features of SiteVision along the way. In this video, we'll be touring the dataset we just made in Trimble Business Center, as well as walking through some of the main features of SiteVision. We'll first start with an overview of the dataset, and from here, you can see that the data has placed itself automatically in roughly the correct location. This is due to the dataset being geo-referenced in the office through both our control points from the initial survey, as well as the use of the correct reference system in Geoid, which we set up earlier in TBC. After initializing the unit and getting a lock on enough satellites, we now need to walk a specified distance, around 10 meters in this case, so that the receiver can calibrate its position in relation to both the model and itself. Once this happens, you can now see the data snap into place. You'll know that this has worked as both the satellite and compass icons on the upper left had now turned green, meaning we're now able to explore the dataset properly. By default, SiteVision displays every layer that was exported from TBC. However, a lot of our work is hidden by the surface we created from the X7 scan. We can temporarily disable this layer by going to the Layers menu by tapping this icon on the upper right. By clicking on the eye icon next to each layer, we can disable or enable different layers. In this case, I'll disable the surface layer called Drainage Ditch and enable the Contours layer, which will show the contours on the dataset. And while we have the surface layer disabled, we can now explore different parts of the dataset and see how they've rendered in SiteVision. We'll start from the top, in the barbecue area. From this side view, you can see the red point that signifies where our primary control point is, as well as a polygon form from surveying the arc of the barbecue area itself. If this is too difficult to see in the 3D view, we can switch to the 2D view instead by tapping the cube on the lower right corner of the screen here. This gives us a top-down view of our data in SiteVision, centered on where we are in relation to the dataset and oriented towards where the device is currently pointed. Next, we'll head into the basin and explore the polygonal grate feature, showing off the inlet where our canals drain into. As you can see, the shape of the grate has been traced by the surveyor and appears at the correct location on SiteVision. Looking below the grate, you can see some of the points that trace the canal itself. We'll drop down into the canal and continue from there. As we go into the canal, you can see the points that the surveyor took to trace the canal itself on one side, as well as an offset measurement done in the office to copy and translate that line to the other side of the canal. Because this particular part of the dataset is quite long, this is a good chance to demonstrate the cross-section and view distance sliders, which are both located on the lower left side of the screen. The cross-section slider creates a cutting plane from the front of the SiteVision unit, allowing you to take vertical cross-sections of the model. While it's only cutting the lines in this case, this can also be used with much more complex architectural or construction models to get an inner look at struts or internal framing. Likewise, the view distance slider also creates a cutting plane, but from the rear of the unit instead. This is useful for longer models, such as roads, railways, or in this case, canals. Doing this helps save the device's battery, and can speed up the rendering times of certain models on your phone, as your phone has less model information it will need to have to process. We'll continue our tour of the dataset at the arch head wall, where you can see how our utilities data from TBC effectively lines up with the existing infrastructure. Since the data in this part of the environment is quite complex both physically and digitally, this is a great chance to demonstrate some of the features of SiteVision's Applications button. Pressing and holding the Applications button in the bottom center of the screen reveals 4 different functions, which we'll be taking a look at here. The note-taking function is located on your left, indicated by the camera and checkmark icon. This lets SiteVision take photos of the data as it appears on the device, and gives you the ability to write detailed descriptions, set the type of issue, designate responsibilities, set responsible team members on Trimble Connect, and give it a due date. These notes are synced online via Trimble Connect, and responsible team members will get an email notifying them of the to-do and what they need to do on it. The next application we'll take a look at is the distance measurement function, which allows you to measure your position and distance in SiteVision via one of 3 methods: current GNSS coordinates, augmented reality, or the built-in EDM. GNSS will measure where you are currently standing in a global coordinate system, while the AR and EDM modes measure to points on the model and points in the real world respectively. This gives us the distance as well as the bearing and coordinates of the measurement in relation to the model. You can also change the name and feature code of the point for easier reference in the office. Now, since this model also has a surface, we can use the cut and fill function to measure the difference between the model surface and that of the real world. This can either use the device's GNSS coordinates with the help of a survey pole or monopole, or in this case, we can use the EDM instead. Measuring to a point on the real world, such as this rock, tells us the approximate height that we'll need to cut or fill the terrain to. Lastly, the grade and distance functionality allows you to carry out distance measurements between 2 points, whether those are on the model itself, in the real world, or to the GNSS coordinates of the unit itself. In this case, we'll be using the function to measure the approximate distances between these 2 arches. While these points both use the EDM, you can mix and match different methods to measure from a real-world point to one on the model, or any other combination of the 3. With the presence of some utility data at this point in the dataset, another feature of SiteVision we'll be going through is Pit View. Pit View allows you to visualize the depth of underground features, such as utility lines, underground cabling, or in this case, these pipes located in our dataset. Pit View can be enabled by tapping the cylindrical icon on the right side of the screen, which will render a yellow hole in the ground, which uses the built-in EDM to help display the pit at an accurate ground level. While in Pit View, you can adjust the size and depth of the pit to help better view the data. You can also tap the drop-down menu to choose between different viewing models of the pit itself. Round mode gives you the opening of the top of the pit, while half round gives you a cross-sectional view to help get a better sense of what's below the ground. Lastly, surface only mode compresses underground data into a flat 2D surface that is superimposed over the ground surface, giving a quick way to trace a utility path while still keeping general spatial awareness.
Out of all the time.